All right. Your next homework assignment is related to WMS, which we're going to begin the hands-on part of that for you today. And that assignment's due on Monday before class. I'm going to be giving you a series of handouts, and so if you don't already have a binder for this class, it might be a good idea to get one or to bring it in, just so that you can take notes to yourself on different steps of the procedure. Of course, I am going to be recording these and posting it on YouTube so that if you have any, if you forget what the steps were on a certain process, then you can refer back to the videos, or you can, of course, always get in touch with me. Today what we're going to do is practice the skills of locating the project area, bringing up maps, and then delineating the watershed. So any questions about that? I've got a handout for you. Let me give you that. All right, so everybody get a copy of the handout? They're headed to the left. So the process that we're going to go through is I'll demonstrate something, and I'd like you to follow along as I demonstrate it, and then I'm going to pause and have you repeat the steps someplace that you're interested in, like by your house, or some watershed that you maybe go hiking in, or where your parents live, something like that. All right, so if you haven't already, start up WMS, and it begins with a blank screen. We haven't yet defined a projection. You can see that it's set to the units of feet. All of that's okay. The activity 1 in the handout is what we're going to go through. This is just some familiarity with where the different buttons are and how to bring up map imaging in the background and draw feature objects on top of it. So the location that we're interested in is near Paden City, West Virginia. And frankly, I'm not even sure where that is, but in a previous research project I worked on, I was analyzing a watershed near there. But I don't think I've ever been there before. But let's go there virtually. The first thing that you need to click is Get Online Maps. And so across the ribbon on the top here, it is the icon is there on the handout, you can see. But if you hover your cursor over these, then it'll tell you the name of the icon. So wait for a moment, and it'll give you a brief description of what it is. So we're going to Get Online Maps. And in doing that, it brings up this locator tool that you've seen before in the demonstrations that I gave.
Does WMS frequently not work?
No, it doesn't frequently not work. It does frequently crash, but I mean, no. Did you boot your computer fresh just now, or were you coming out of sleep or something like that?
No, I didn't restart it just now.
Yeah, sometimes like if you're in standby, programs, regardless of whether it's WMS or something else, don't execute the best. But usually what causes WMS to crash is really big data sets, and we haven't gotten to the point yet where a crash should be likely. So my suggestion is maybe just reboot your computer and start WMS after a fresh reboot. All right, so again, what we do is we are going to bring up this online maps, and then yours, I don't think, will at first go to Paden City. It'll probably show the entire world, right? Is that the map view that you've got? And so here in the search tool, you can just type in Paden City, West Virginia, Paden City, comma, WV, and then jump to search location, and it'll probably bring up this same view. Okay. Now, what it says in the description here is that there's a watershed immediately north of the intersection of Gamble Run and Paden Fork Road. Now, sometimes that'll be a little road, sometimes that'll be a big road, and you may need to also, in parallel, go to Google Maps to kind of locate some of these spots. I mean, in this particular case, these are big roads, and if you look, you can actually see here's Payden Fork, and here's Gamble Run, and here's the intersection. But sometimes they're going to be small, little obscure roads that people give you a description for the watershed. And so you can just Gamble Run and Payden, what was it? Payden Fork Road, Payden Fork, West Virginia. So sometimes you can just type in the intersection of a couple of roads, and it'll, here's Gamble Run, here's Payden Fork, and so this is the intersection that we're talking about. So my point is that sometimes, as far as like finding the appropriate location, you'll have to swap back and forth. And so it's this intersection, and it says there's a small watershed immediately north. And so if we zoom in a little bit, you can already get a sense from the shading on this map in the background that here's that watershed I'm talking about. Can you tell from the shading that there's a ridge line there? And so it looks like this is the northern extent of the ridge line. So I think I'm zoomed in as far as we need to be here. So when you click OK, feature requires a new global projection. Select the projection in the following dialog. All right. So let's set the projection. And you probably don't have anything in recent projections, but I do because I've opened up the program here. Let's go into geographic, projected. Projected coordinate systems, UTM, NAD 83, and NAD 83 zone 17 north. Okay, so again, what we did to get that was global projection, set projection, and then projected coordinate system. Scroll down to UTM. Scroll down to NAD 83. And then we want to do NAD 83 UTM zone 17 north. All right. And then for the vertical data, instead of local, we'll just set it to NAVD 88. And I don't know as much about these projections as I probably ought to, other than WMS usually figures it out once you just set which zone you're actually working in. And all of West Virginia is in zone 17, and so was everybody able to set the projection okay? Okay. So now that we've set the projection, you can bring up these maps. And the three maps that we want to have is the world imagery, the world street map, and the world topo map. And I don't know, I don't think we can do more than, oh, maybe you can select more than one at a time with the control button. So use the control button and your mouse cursor and try and select all three at the same time. I don't think I've done them in a batch like that before, but click OK, it works. Over on the left side, it'll add those as layers to the project. Let me pause here for a moment. And now control, select that, and that.
Can you do full street map?
Okay.
We got ways.
Don't have WMS? Yeah, I sent you the link a couple of times via email. Figure it out before today's class.
World topo, street,
They've been installed beforehand, huh?
It's moving. Very much.
All right, so let's look at what it did just now. We've added maps, and over on the left side window, this is where different files are displayed. And so there's a topographic map, a street map, and then a world imagery is like aerial photos. And so if you turn one of them off, so we've turned off the topo map and the street map, now you can see here's the overhead view of what's called a DOQ. And it's basically just an aerial photograph. But we can switch that off and go to the street map and find the intersection. Here's Gamble Run and Payden Fork, and so that watershed that we're interested is here, and maybe we can see it a little bit better with the topographic map, because topo maps typically will have these contour lines. So these maps can be streamed or they can be saved locally. And right now what we're doing is anytime you pan from side to side or zoom out or zoom in, it's going to take a while because it has to download a new version of the image from the server. So like right now, for example, the topographic map is shown. And if I zoom out by clicking over here to the zoom, and right now it's saying plus, that would be zoom in. But if you press the shift button, it moves to minus. And so I'll zoom out by clicking, left clicking after having the minus. And so here's that same shape that the shading implied from before. So we can just kind of manually try and delineate the shape of that watershed and the area of it. So on step 2, actually I haven't yet showed you how to save these images as local. So right now the topographic map is showing. If you right click on the words World Topo Map and export, then what it's going to do is it's going to save a local copy of it so that you don't always have to stream the image file from a server. And that can be useful if you don't have an internet connection and you're going to be doing work on your project file somewhere and you don't have an internet connection. So we'll just click OK, then it's going to offer for us to save it, and I haven't yet saved this anyplace, and so I probably ought to do that. WMS demo Monday. All right, so I've exported that image file. It's downloading it now. You can see down at the bottom in red, it gives you kind of a play-by-play on what it's doing. And I probably also ought to save this file itself that I've been working on. I'll do it in the folder that I've just created, WMS Demo Monday. And so this one is just Activity 1. Activity 1 is what we're doing, is learning about how to bring up maps and locate watersheds and such. So now I can turn off the World Topo Map, and then what it's showing is this downloaded version rather than the streamed version. I could switch that off and go back to the streamed version, but you can see on GIS data what it says is processing at times when like you're zooming out and it's still trying to download the data from the server. So zoom out to the extent where you can see the shading, and let's trace the shape of the watershed manually by going over here into the map module. There's these buttons across the top that take the program into different modules. And the map module is for drawing on top of the map. There's this drainage module, which is more about getting hydrology related parameters and characteristics like the curve number, the soil type, the land use. There's the hydrologic modeling module, which is about setting up the data for the rational method or national streamflow statistics. So different one of these modules, you switch between modules to do different things to the data. Or, like I've previously told you about the hydrologic modeling wizard, it will step you through the various modules that you need to be in to do the work in the workflow that's implied by the hydrologic modeling wizard. So you don't necessarily have to manually switch between these modules if you're using the wizard, but some people will, without using the wizard, just kind of manually know what steps they want to go through. So the module we should be in right now is the map module. So click on, it looks like a compass rose, little orange symbol in the compass rose. So with the view, like you've zoomed out with the topographic map, so you can see the shading, and then let's try and draw, create feature arc. So over on the left side are these tools that we can use for creating points, creating lines, arcs, selecting. So we're going to create a feature arc, and then draw along the ridgeline to try and estimate how big is this watershed. And so I'm going to start at the intersection of Paden Fork and Gamble Run, and then just occasionally clicking as I go up that ridgeline till you get to the top here, and across the top of the ridgeline, and then back down again. You'll get progressively better at recognizing what is the boundary in a watershed. And then double click at the end. So you can see all the points that I clicked along the way. Now right now these are each individual arcs, but I can have it build a polygon, which is a single shape. So switch, once you've created your series of lines, switch to the Select Feature Object tool, which is just this arrow cursor, and then right-click on this, and then we're going to right-click Build Polygon. So now that it's a polygon, we can select that polygon, and it has units of area. Over here on the right-hand side, it tells me that this watershed is 120,000 square meters. Well, 120,518. That's not a particularly useful unit to know as far as the area goes. Let's see. I think the basin area of square miles is only once we delineate the watershed, but if we're doing this manual approach, we'd have to convert it. So 120,518. So of course Google does units conversion. So just to get an idea, 120,000 meters squared to acres. That watershed is about 30 acres that we've just traced. So about 30-acre watershed. All right. So now, to reinforce these tools, I'm going to pause and save this so that you've got it. Save it. And then click on this button to the left, the New button, and it wipes the slate clean. And follow those same steps at a different location that you're interested in. Maybe by your house, in some rural area that you've hiked through, but select another location and go through the same process of bringing up the maps, identifying the boundaries of the watershed, and then drawing it using that feature arc and building the polygon. So I'll do that, but I won't narrate through it as I do it for myself. let's do something a little bit more robust. Let's have the computer do some of the heavy lifting. So if you haven't already, save this just to make it a habit. We'll save the project, and every time you do it, I'd suggest using a new folder for each project that you make, because just to reinforce what I showed you in a previous class meeting, when you save a WMS file, it actually is saving several different files. And so it's not just the .wms, but there's a lot of these. And so that's why it's good for everything to kind of be in its own folder. So I'm going to create a new folder that I'll call WMS Demo Monday Activity 2. There we go. Now I've got a new fresh folder that I'm going to use. So this one was Activity 1, the second part. All right, so start fresh with the new button. Throws everything out that we've done so far. You can see on the handout that it says that there's a stream that goes under I-64 near Darnell Road in Huntington. So we want to compute the area of the watershed, the maximum flow distance of the watershed, and the average basin slope. All right. So for this, let's go into the hydrologic modeling wizard. So this is the one with the little hat and a couple of dots underneath the hat. Looks like maybe it's roller skates or something. I don't know. But if you hover your cursor over the icon, then it'll say Hydrologic Modeling Wizard. And then this brings up this step-by-step workflow where it reminds you certain things that you need to do. So the first thing, for example, with the project file name, let's browse to a location where we can save our work. I've got this WMS Demo Monday Activity 2. So I'm going to call this Activity 2 as my file name and click Save. And then once you click Save, up at the top, you can see that we've got a defined file name and it describes the path that it's saved in. Okay, so then next, and we need to define the project bounds. And this is someplace in Huntington. You can see we don't yet have a projection defined, so we need to do that. That's the one where we're telling it global projection, projected coordinate system, and by now you probably have a recent projection of NAD 83 zone 17, so you can choose that. And an elevation vertical datum. The units need to be switched over to meters. No, wait, I'm trying to remember. Feet. Let's just leave it with feet. It'll be obvious if we've made a mistake. All right, so then the boundary, click Define, and this is now going to be Huntington. It goes to the previous view. So previously I was in Ona, maybe someone was in Charleston. It'll just go to, in this virtual Earth map locator, whatever the last place was that you looked. So now we're in Huntington. And jump there, and it's way too zoomed in. The handout gives you an idea of what zoom level you should have. And another thing you're going to be good at is using like the curvature of roads as kind of an indicator of where things are. And so pan over and look on the handout I've given you. There's a couple of distinctive shapes. There's the bend here, and I think this is maybe the Mud River. So you see that bend. So try and reproduce the view on your screen to make it the same as the handout. So I think I need to zoom in a little bit further. That's getting more like it at this point. And the reason why is we're going to try and get the entirety of a watershed, the outlets near Darnell Road going under I-64. So here's the creek. It's labeled on here as Russell Creek. Do you see that? We're going to try and delineate the entirety of the watershed that feeds this Russell Creek that goes under 64 near Darnell Road. So this is the stream. And so we need to get the entirety of the watershed, and I think at this zoom level we're going to get that. All right. And I showed you what it looks like when you don't have the whole watershed. But just click OK at this point, and you may have to click on the WMS icon to bring the wizard window back to the foreground. So it's got the coordinates picked out of the corners. And click Next. We're going to use the web services for downloading the elevation data that we need. Okay, so use web services. And turn on worldwide elevation data. And click on the download data from web. And it gives you the suggested zoom level, like the precision of the data. So at this, it's suggesting that each one of the pixels should have a 15 meter by 15 meter size. So we'll just go with that. So click OK. And then down here at the bottom, it'll just very briefly give you the downloading indicator, but then you can tell that it's done when it brings in the contour map in the background there. Okay, so let me pause for a second and see if everybody's got the elevation data downloaded.
Yeah, do that. You said that happens. Like minimize and re-everything. Yep, there you go. I'm pretty sure I know what you're doing. Got that to the next.
And it's creating like this little heat map. This heat map that we don't necessarily need, but with this, what we're looking at is the contour lines of the elevation data. So it's tricky to know exactly which stream we're going to want, but we'll bring up some mapping in just a minute. So this is just like it's representing based on all of those pixels that it downloaded. It downloaded points of elevation data. And so when you click Next in this Hydrologic modeling wizard, then click on TOPAZ. Horizontal and vertical units must be the same. All right. So I probably need to switch over to meters for the vertical units. Okay. I think we can do that here. Vertical units. All right. I'm going to redefine the units here. Set projection. See if I can switch it to feet. No, meters. We're in feet right now. That's the problem. Units, meters. All right. All right. So again, if you get that same error message, what we need to go is into the project projection and switch the vertical units to meters, whereas I think before I had left it in feet. All right, so it's in meters. Now, hopefully it'll let us do TOPAZ. Compute TOPAZ. There it is. All right. So TOPAZ is that computer program that's basically comparing all of the cells to adjacent cells and trying to find out for a given cell which of the ones that surround it has the lowest elevation. And then it determines a flow direction from that. And by doing that to all of the cells in the entire elevation data set, it can predict where the low points are. And so see these blue lines? These blue lines that have been drawn represent where a stream is going to form simply because that's the lowest point in the watershed and there's a certain amount of upstream area. So here where it says 0.5 miles squared, you know, if yours wasn't set to 0.5 miles squared, it's probably going to look different. Like if it was set to 0.2, then these blue lines are shorter because it's only going to show a blue line when there's 0.2 square miles. But if we do 0.01, then there's going to be a lot of those blue lines because anytime there's at least a hundredth of a square mile of watershed area, then it will predict that a stream begins to flow at that threshold level. So for now, let's just do 0.05. And let me circulate around to make sure that everybody's able to get TOPAZ done. Okay, so we've got elevation data. And these blue lines are called flow accumulation cells. And that's just the program predicting where a stream would form because of the depressions in the elevation. And so what we want to know is what's the watershed area for the stream that goes under I-64 near Darnell Road. So we need to find Darnell Road. Let's bring up a map in the background. So get online maps, and we'll have it do the street map. And that's going to allow us to find out where was Interstate 64. Okay, so here's Interstate 64. And Darnell Road is this one. All right. So what we're going to do is we're going to put the location of the outlet of the watershed on the other side of 64. So like on the north side of 64. So just zoom in to where you've got the world street map, and you can see it's this main segment of the stream that we're going to want to delineate. Does everybody have basically this view or some equivalent of it up where you can see the flow accumulation cells? Your contour lines are drawn on top of this world street map. Long area, you know, like when you're at the stage where you're defining the project bounds, if you are zoomed out too far, it's going to make these problems so much more difficult. So it really pays to be pretty careful about what your view looks like when you're at this phase of defining the project bounds. All right, so what we've got is these flow accumulation cells, and now I'm going to tell it what location is the crossing point that I want to delineate for. So I'm going to bring up the hydrologic modeling and choose outlet location. So that's just the next step after TOPAZ. You can skip between steps on this left side. So we did TOPAZ, brought up these flow accumulation cells. So the next step, choose outlet locations. And so create outlet point. It's this button at the top. Now be very careful not to click in the wrong place, because if you create an outlet in the wrong location, they can be pretty cumbersome to delete. You can see that there is a tool to delete an outlet point, but sometimes it works, sometimes it doesn't. So what I'm going to do is I'm just going to click on this cell that is after the stream goes under Interstate 64. So I've dropped that outlet and then click Next and Delineate Watershed. So click on the button Delineate Watershed, and up down in there at the bottom it's giving me the play-by-play. So we've got almost all of the watershed except for, you see this little part at the top, this flat line. I gave you the warning in the previous demo that anytime you see a flat line, that means maybe you're not zoomed or panned at the right spot. So technically what I'd need to do is I'd need to repeat this process but pan down a little bit so that I got the entirety of that watershed. Okay, so in just the few minutes that we've got left, what I'll do is I'm going to write down, I'm going to show you where we can get the data that it's asking for, because what we want to know is the watershed area, maximum flow distance, and basin slope. And you can see once it delineated the area, it listed that in the display. See where it says area 1.82 miles? Well, I need it in acres. There's a way that I can change what is displayed and what units it is going to show. So here in the drainage data, what I brought up was the display options. And so it's this button that looks like a monitor screen on the ribbon across the top. So click on display options and then drainage data. And I'm going to have the area, basin area, and I also want to have maximum flow distance. So that's this one. And then I also want to know basin slope. So here I'll click basin slope. And then when I click OK, it'll add those. So I've got the maximum flow distance, the area, the basin slope. I think I might be able to coax it into giving me different units. Instead of square miles, I might be able to get it to do acres. Here in the Hydrologic Modeling Wizard, project bounds. No, it's not there. There it is. Compute basins areas in acres. Yeah, so it's on the same screen as TOPAZ. And then refresh.
Dr. White.
Yeah.
If you happen to go back to the modeling wizard, it's on the Delineate Watershed tab.
All right. Delineate Watershed.
And then
Units. Ah, thank you. Yeah, so acres. Okay, Delineate Watershed. It's going through the process, and then hopefully it should report the units in acres. Converting feature nodes to vertices. Well, I hope it does it quick because we've only got 1 minute left.
Dr. Wade, while that's running, where did you go again to get the other information to pop up?
That is in this display options.
Okay.
And then once it brings up the display options, you want to switch to the icon that looks like this, watershed basin. And it'll have a checklist of things here. Updating drainage units to feature polygons. Oh, I don't know if it's going to finish doing this, but once it gives you the area, maximum flow distance, basin slope, I could write it on the page here, and then you see, all right, so it looks like it finished. So 1,166 acres. You can see the maximum flow distance, the basin slope. I'd like you to reinforce these by going through the same steps for a watershed that you're interested in. So identify like a crossing point where a stream goes under a road, get the elevation data, locate the outlet point, run TOPAZ, that whole process. I suggest that you do that just so that it's familiar and fresh in your mind. We're going to move on to new tools in class on Wednesday, so if you didn't have WMS installed today, absolutely, positively have it installed and operating for Wednesday's class. I'll see you then.